Hello viewers, welcome back to the Multimagic channel. So this is a session 5 on video series. So in this particular session we will discuss about how to capture raw frames from the camera and encode it, encoding with the help of X264 codec, and then write that encoded data into the file. So let's see how to do that. So this will be an interesting session since we are capturing it from the camera instead of from the file. So before going further, let's see what we have discussed in the last session. Actually, in the last session, in the video 4 of the video series, we have gone through how to convert an RGB images to MP4. So first we have RGB images. We then convert that into YUV, and that YUV data we dump into the AV frame, and that AV frame will be sending it to the send frame API of the FFmpeg, and here the encoding starts in this within this API. So whatever codec we pass in the initialization context, that particular codec will be used. So here X264 codec we used, and that will convert and it will send the compressed packet, and that compressed packet we will be writing it into the file. So this send frame, which codec which used, all those details will be giving it in the initialization, like all these details. So this is what we have gone through in the last video, like converting raw images to MP4 with the help of FFmpeg APIs and X264. So now this session, it will be an extension of the previous session. So in other way, so here we'll be having FFmpeg initialization for both input and output. So because here input is not static, input is coming from the camera. So we need to initialize the input context, and also we need to initialize the output context. So here the input context contains all these parameters, and we need to prepare the video decoder, and we need that's what we need to do for when it comes to input context. And when it comes to output context, we need to additionally declare this AV stream, and then we need to prepare the encoder, and then we need to open the output file to write the encoded data. So here from the camera, we'll be getting the raw frames or raw video, and that raw video data will be sending that particular packet, and that particular from that particular packet, the we will be receiving the frame. So here in this case, since it is a raw, I mean the packet and the frame is same actually. So whatever, so you see there's no compression and decompression here, whatever, it is a raw frame, but first it is preserved in the packet, and then from the packet we just copy the data into the frame, and that frame will be sending it to the encoder like send frame, and then we'll be receiving it in the packet, and all the necessary context initializations will be happening here within the declarations. So this is just the high level overview of what is happening. So let's jump into the code now and then see what is happening actually. Yeah, so this is the camera to encoder. So let me go to the main function first. Yes, so before, let's quickly go through the code at high level. See, as I mentioned, first I need to initialize the FFmpeg input, and then I need to initialize the FFmpeg output. So let's jump in what is there inside the FFmpeg initialization. So here, let me scroll up a bit. Yeah. So here first you need to, these are all the context in output context, and above are the input context. So let me see here. Yeah. So these are all the initializations for the input, and these are all the initializations, I mean the required structures for the output. So in the initialization, so first we need to allocate memory for this input format. First we need to allocate memory for this input format context, and then you need to register all the AV devices. So we'll be using a new library or new shared library from the AV called avdevice. So you have 8 libraries provided by the FFmpeg avdevice, avutil, avimage, SW scale. So in that we'll be using here avdevice. So we will first will be devising registering all the devices here, and then later we will be opening this particular video webcam. So for Linux, so since I'm running on Linux, for Linux devices we use this video for Linux too. and for Windows you need to use dshow, and foundation for Mac OS. So we will be, so like in the Linux everything is a file. So this particular webcam you can access with the help of /dev/video0. So this is our webcam, how to access opens it. So AV format opens open input will capture the frames from this device and store all the packets inside this input format context. Okay, so now in the during this you need to just initialize AV format find stream info, and then you need to see whether we are getting audio stream and video stream. For now we are just only capturing the video, we are not capturing any audio details. So we will be just from the input context we will be iterating over the streams, and if it is video we just increment the video stream index, that index is needed, and here we are actually getting the number of frames, and also we are getting the time-based timestamps for the input frames. So all those details we are capturing, and then we are actually finding the decoder actually. So I mean you just need to pass whatever codec ID is there inside this context, and then we will be getting the decoder details. So here I am printing all the decoder details. I mean what is our input frame here. So our whatever we are capturing from camera. So what is the codec ID which is used, and what is the pixel format, what is the resolution, what is the bit rate, FPS, all those details we are printing here. So I'll just stop here and let's quickly check. I already saved this info here, so let's check here. So if you can see from the camera, the whatever raw, so the decoder type codec ID is raw video. So you can see here the codec ID. So we have different data coming from, whether it can be file or whether it can be from camera or whether it can be stream or whatever it may be. So the input data here, it is of type raw video. So for this raw video means exactly the packet and the frames both will be of the same size. Okay, so here, so the video decoder is a raw video. Typically if it is a file you can get MP4, MP3, like those. And then here the video streams are, it's a long name, and here it is the codec ID, and the pixel format is YUV 422, and resolution is 640 into 480, and the bit rate is this, and the number of frames per second you are getting is 30, and this is the time base actually. So this is the input details that is being captured from the webcam by the FFMPEG AV open input and our AV device. So while encoding we need to use some of these parameters which are part of the input, and we just use it for the sake of simplicity, like similar parameters while encoding those frames. So now let's move on. So now we have initialized all the input details. So similarly you have to initialize the output. So for you need to open the output format context, and you need to allocate all these memories, and you need to, so here I am encoding the output format context with H264. So there are a lot of codec IDs available, so you can use any of these things. Ensure your FFmpeg should be built properly with the help of these external libraries. So that build process and everything we have already covered actually in the earlier videos. You can go through it. So now here we are using this particular X264 video codec, and now we are allocating the memory, and this is very important block. So how do you want to encode your data coming from the camera? So what are the encoder properties? So I'm telling my height should be the same of the input, width is same of input, and sample aspect ratio is same. And here it is the important point here. I am using here YUV 420p. Since I am using X264 format or X264 encoder, it supports only YUV 420 or YUV 420 P and YUV 422p. It doesn't support YUV 422p. So if you can go to the documentation of the X264, there you can see what are all the pixel formats supported by a particular. So now I want to convert this to the YUV 420p, and this is the property of my encoder. And bitrate I'm using 3 same, and max B frames I'm putting as 3 for simplicity. You can use 1 or you can use 0 or whichever, and GOP size is a gap between the frames. And here these two parameters are also very important. So the timestamp is nothing but the input frames. It is close to 30. So this is the timestamps we need to use for the output codec time base actually, and the stream time base is nothing but the input codec context time base. So whatever we are getting actually. So these are all the important parameters to ensure that we define the encoder properties properly, and then we call the respective APIs in the FFmpeg, and the rest will be taken care by the libx264 libraries. So now we open the output codec context, and then we open the output header, and then we open the file info. So it's ready now. So it's like the input is ready, the output is ready. So now we need to actually start the processing. So the important step here is, so here I'm just capturing the camera for 5 seconds, whatever the argument that we are passing from the command line, 5 seconds, 10 seconds, 15 seconds. So for that much amount of time, it continuously captures the frame and then it encodes it. So here we need to just do small math here. So first you will do AV read frame. So AV read frame, and we are passing here input format context. So this particular input format context is associated to our video device, and from this video device we'll receiving a packet here. Okay, so for this packet I am just resetting the present timestamp, because while you are capturing from the device, it uses the timestamp or the current system time like that. So to avoid I mean, after capturing, if you're playing back the video, it will show like 2 hours 10 minutes, like different timestamps. To avoid confusion, we need to reset the initial present timestamp from the first packet. So for that I have assigned this AV no options, which is like 0000s, and I'm just subtracting that with the actual value. So now I am preserving my initial PTS, so which will be more human readable now. So that way I'm just applying some math to safeguard the packet PTS and DTS. So now the actual math begins as shown in the presentation. So first we already got the packet came from the video device, and you will be sending this packet, and here I will be actually, if this packet is of compressed packet and it is uncompressed, and that particular uncompressed frame will be receiving here, it will be stored to the iframe. In this case, since the codec ID is raw data, actually the packet and the frame data is almost similar, with respect, just maybe some header details are different. So finally, whatever we are receiving the frames here. Okay. So now this frame we need to encode actually. So before encoding, as I mentioned, as you have seen here, so here we are getting the type as YUV by UV422. So but our codec supports only YUV420p. So first we need to convert this frame into YUV420p. So that's the reason I have written this particular function called convert frame, where it converts the YUV422 by UV422 by YUV420p. So let's go to this convert frame, and then here actually you can see here this is the destination format, and this is the source frame, and I'm written to the destination frame. So I'm allocating the memory, and I'm just format whatever format I want to convert, width and height I'm just using, and remaining all other parameters I'm just copying whatever there for the actual source frame. So whatever parameters or properties exist for the source frame, all the things I'm copying to the destination frame except the format. So all the format I need is YUV420p. Okay, so now I am converting this to this. So this is the destination frame, and then I'm converting AV, I'm extracting, I'm copying the data into this from the source frame to the destination. I'm allocating the memory for the destination frame here, and after allocating the memory, I am just copying the source info into the destination. So here the source frame, source height, source data, everything we are scaling it to YUV420p. So now inside this destination frame, our particular frame is there in the format of YUV420p. So we just need to scale it again. So this is just the context here, and actually we are copying the scaling the data here with the help of this SW scale API. And then finally we are freeing this context. So to keep it very short, we are converting YUV UV422p frame to YUV422p. In that process, first you need to first allocate a destination frame and copy your respective all other parameters and allocate memory AV image, and then you need to just declare on scaling context, and with the help of this context here you need to provide in the context from which to which you are converting. So you are converting from YUV422p, destination format is YUV420p. So that context we are passing it here, and we are telling copy all the data and scale it accordingly. So internally this API converts one type of data to other type of the data that is provided inside this software context. So finally we are freeing the whatever memory allocated. To keep it, just to reiterate, we just start reading the packets, and this packets first we are preserving the timestamp of the packets. After preserving, we are sending that packet, and once sending the packet we receive the frame. So after we receive the frame, we convert that frame to YUV422p, and I'm just printing all the details here. What is the frame, PTS, GTS, size, width, height, pixel format. So now I need to encode this destination frame. So in the encode frame, as I mentioned, we'll be simply going through this picture type is none. I'm sorry. Yeah, in so yeah, so in the in encoding actually we send this input frame type, we just declare this picture type as none, and then we send this frame and in the form of a input context video actually. So in this input codec context video we have already set, like, okay, sorry, this is the output codec context video, and we already set that this output codec context video uses the x264 codec to come to encode. So first we send the frame, and this send frame will actually compress this particular input frame, and the compressed format is called packet, and the kind of codec we use to compress the data is x264. And now we are receiving that frame output packet, and yeah, this output packet is now sent for the encoding. So we will be writing this output packet into the file AV write file, AV packet rescale, all those things. So here I am writing this into this, and then finally, yeah. So this is how you encode the frame from the output packet. That output packet you just write it to the file. So while writing to the file, we just take care of the timestamps like PTS details. Again, we will be all setting this here. I will be sharing this code in the GitHub so you can go through it. So now we have received, so it is all the things runs in a loop actually. So we receive the frame, and that received frame we convert into YUV420p, and that frame we are compressing it with the help of x264 inside this encode video, and this functionality keeps on going for whatever number of seconds we do it. So let me stop my camera feed now here. So now let's go to, so I already built it. So now I am telling capture camera for 10 seconds. Okay, so let's see it started. So this is my timestamp speed. So it is like 30 frames, right? So it might take around 150 frames, or depending upon the processing, all those things, it might take sometimes less frames. Yeah, so because I'm running different tools, so it could able to capture 108 frames at this point. So these are the I frames, P frames, and B frames. So let us play that video quickly. So it is in my workspace, and it's in my video basics, and this is the project. Yeah, and let's play this video. Let's play this video. Yeah, yeah. You can see here it's already playing. I captured it for 6 seconds, 7 seconds. Yeah, actually captured for 10 seconds, but it is showing 7 seconds because actually my recording tools are playing in the background. So that's the reason, like some time mistook for them, but generally you will be getting, if you're not having any capture tools behind, it will be very smooth. Yeah, so yeah, that's also you can see here. So this is a very, I will share this code in the GitHub. So to make it very simple, we just use different FFmpeg APIs, and then input context is pretty much important, and then you just need to ensure using these while loops you continuously decode the frame and encode the frame continuously. So hope everyone enjoyed the video. In the next video I will be coming up with one more video on the video session. Like I will thanks a lot everyone, have a good time, take care, bye bye.